Okay, exercise 312, simultaneous equations. Simultaneous is when you've got two unknowns, two equations, each with two unknowns. See, if you've got one unknown, you only need one equation to solve. If you've got two unknowns, you must have two equations to solve. If you've got three unknowns, you need three equations, and we're doing three unknowns next week, okay? So there are two methods, elimination or substitution. The time when you would use, see the first one, this first question here, you could use, elimination or substitution. See, you could quite easily make B the subject of the formula for this one by taking the minus B over there, minus 6, right? And substituting in there and use substitution method. Or you could use elimination method because you could just multiply this second equation by 2 and either add or subtract whatever you need to do both equations. But this second example here, I would definitely use elimination method. I would not make y or x the subject of either of those and substitute it in. All right? So there are times, 3.12 simultaneous equations. We're going to look at both the elimination and the substitution methods. Now, let's look at those two. Y equals 3x minus 1 and y equals 2x plus 5. Y equals that and y equals that. Doesn't it make sense that 3x minus 1 would equal 2x plus 5? If y equals this and y equals that, doesn't then the 3x minus 1 equal the 2x plus 5? Because they're both equal to the same thing. So you can call this equation 1. And you can call the other one equation 2. So that's equation 1, that's equation 2. And you can just say substitute equation 1 into equation 2 or substitute equation 2 into equation 1. It doesn't matter. Put them equal to each other because they're both equal to y. I'm going to put, it doesn't matter which way. I'm going to write my 3x minus 1 on my left. See, put that in. I've actually put 1 into 2. Yes, I have. Equals 2x plus 5. But it wouldn't matter if you wrote sub 1 into 2 or 2 into 1. It's the same thing for this particular one. We good? So this is your simplest type. If you get one of these, it's great. So 3x, what have I got now? Minus 2x equals 5 plus 1, so x is 6. Now, you know, really, these are two straight lines, you know. We're not finished, by the way. X is 6. What else do I have to do? See, two equations, two unknowns, x and y. That's why you need two equations, because you've got two unknowns. Then we're just going to substitute x equals 6 into either equation 1 or 2. Let's go equation 1. And I've got y equals 3 times 6 minus 1, so y is 17. So that's my solution. X is 6, y is 17. Now, what does this really mean? You know y equals 3x minus 1 is a straight line. Y equals 2x plus 5 is also a straight line. Do they have different gradients? What's the gradient of the first line? And the gradient of this one? Because they're not parallel, they will cross over somewhere. Two lines that are not parallel will meet eventually. Okay? And these two lines, if I sketch them, would meet at which point on the number plane? 6, 17. So if I happen to do just a quick sketch, how do I sketch this one? What's the y-intercept? -1. Would you say it's steeper than the other line? So I'm just going to draw it a bit steep. The other line crosses at 5. I'm just going to pretend that's up here somewhere. I know it's not to scale. It's not as steep. If I did draw them, right, this is the y equals 3x minus 1. That's the 2x plus 5. This point of intersection would be 6, 17. I know that's not to scale. All right? That's what simultaneous equations means. So if it's in the context of, you know, a question where two lines are intersecting, it's the point where the two lines cross. Okay? All right. Next week, we're going to get you to solve something like 3x minus 1 is greater than 2x plus 5 using graphing. where's one line above the other. And we'll do it with absolute values as well. Right, so when we do functions, we're going to do a lot of graphing, a lot of interpreting equations and stuff like that as well. This first method, it is substitution. It's substitution. I'm subbing 1 into 2, right? This method, I want to use substitution as well. Look, I actually could do elimination as well, but I'm just going to show you with substitution. So, actually, it's a pretty good one to use elimination for because the 4x's are the same. But I'm going to do substitution anyway. So, if I was to do elimination, would I add equations 1 and 2 or subtract equations 1 and 2? Yeah, because 4x minus 4x is 0. That's, all right, actually, so anyone started substituting yet or no? Or you want to eliminate? I'll go. Look, if I want to eliminate, I would go equation 1 minus 2, and let's go. 4x minus 4x is 0. 5y minus y is 4y. 2 take away 10 is negative 8. You can already see what the answer is. What is it? Yeah, 4y is 8, y is 2. Sub y is 2 into, doesn't matter which one, into 1. This one's easy. 4x plus 5 times 2 is 10, plus 2 is 0. 4x is negative 12, x is negative 3. That's elimination method if either of the x's are the same or either of the y's are the same. If I did decide to use substitution, or if I wanted to substitute, I would rearrange equation 2. But look, I'll tell you, when you substitute when one of the equations is in the form of x equals or y equals, that's when you substitute. All right, I can rearrange equation 2 and get y equals what? Negative 4x minus 10. So rearranging number 2, I get that, and then I'm going to go sub in 1. So this is substitution method. Let's say I gave you the question like equation 1 was 4x plus 5y plus 2 is 0, and y equals negative 4x minus 10. You would definitely substitute. So I'm now going to sub this into 1, and I get what? 4x plus 5 bracket, negative 4x minus 10 plus 2 equals 0. I know this is longer than the other one, but I just want to show you substitution. 4x, what? Minus 20x minus 50 plus 2 is 0. This is a pain, isn't it? I'm going to put the x's on the other side. I think I've got, oh no, it's all right. Minus negative 16x is what? 48. X is negative 3. And then you would sub x is negative 3 into, I'd go into this y1. Into y equals negative 4x minus 10. And you get negative 4 times negative 3 minus 10. And you would get that y is 12. 2. So x is negative 3, y is 2. That's substituting. You'll often use substituting if one of the equations is easily written as either x equals or y equals, and then you'd substitute it into the other. Obviously this one you'd probably use elimination, would be better, quicker. But just showing you how substitution would work. All right? Question 18. So here's equation 1, 3k minus 2h equals negative 14. And equation 2 is 2k minus 5h equals negative 13. That's equation 2. So you would never ever do this one by substitution. Ever. I want to eliminate here. Now, what do you want to make the same? The h's or the k's? K's are easier, yeah. All right, so, but I did want some opposite signs. Can we make the h's the same just for demonstration purposes? I want to make the h's the same for demonstration purposes. All right, so that means equation 1, what are you going to make the h's into? 10h? Equation 1 times what? Normally you would not do this, but I want to demonstrate some negatives. What do you get? 15k minus 10h equals, 14 times 5, negative 9, negative 70. I know it's a bit yucky. I'm going to call it equation 1a. Normally you would not do this. I'd multiply the first one by 2 and the second one by 3, right? Then I want to do equation 2 times what? 2. And I've got 4k minus 10h equals negative 26. I'm going to call that equation 2a. I mean, look, you can call it equation 3 and 4, but I like 1a and 2a because I know that 1a came from 1 and 2a came from 2. Now, the reason I've done this, are you going to add 1a and 2a or subtract them? You're going to subtract them because they're identical in sign. When negative 10 take away negative 10 is negative 10 plus 10. See, you know, if we multiplied the first one by 2 and the second one by 3, you would have had 6k and 6k, and you would have subtracted because they're 6k minus 6k is 0. Now, just because you've got negatives, these two are identical. If you take something away from itself, it's always 0. So we're going to go equation 1a minus equation 2a. Now, what I like to do when I'm doing it, I like to put minus, put them in there, especially if there's lots of negatives around. So 15k take away 4k is 11k. Negative 10 take away negative 10. Isn't that 0? And negative 70 take away negative 26 is negative 70 plus 26, which is negative 44. Now, of course, because I multiplied by 5 and 2, my numbers are a lot worse than what they would have been is if I multiplied by 2 and 3. They're a lot bigger. But I just want to demonstrate the two negatives. So k is negative 4. And then we just sub that in whatever you like. Don't go to 1a and 2a. Numbers are too big. Perhaps sub it in 1. Whichever one looks like it's the smallest numbers. So we've got 3 times negative 4 minus 2h is negative 14. Negative 12 minus 2h. Notice I'm doing every line. You don't want to mess up. Especially with all the negatives. Write it all out. So I've got negative 2h is negative 14 plus 12. I know it's a lot of writing. And I could have just swapped sides. But h is 1. h is 1. So h is 1, k is negative 4. Solve these two simultaneously. Equation 1 and 2. I want to multiply equation 1. I'm going to go for the 6 q's. Okay? I'm not going to multiply by 2 and 5. I'm going to multiply by 3 and 2. So equation 1 times what? So maybe over the side, this is what we want, 6q. That's what we're aiming for. So equation 1 times 3. 15p plus 6q plus, is it 54? Equals 0. Equation 1a. Equation 2 times 2. 4p minus 6q plus 22 is 0. That's equation 2a. Now, look at the 6 q's. They're same magnitude, opposite signs. Do I add or subtract 1a and 2a? I add them together because if you add two exact opposites, you get 0. Negative 5 plus 5 is 0. 6 plus negative 6 is 0. Do you get it? If you subtract, you will get 6q take away 6q, which is 12q, and you do not eliminate. So we are going to add the two equations together. So it's 1a plus 2a, and that gives me 19p plus 6q minus 6q is 0, plus 76 is 0. I'm hoping it's about 4, is it? No, yeah. So 19p negative 4 is negative 76. P is negative 76 over 19, which is negative 4. And then we're just going to sub P is negative 4 into, you know what? Which one? Let's go into 1, because then you won't have a negative 3q. Into 1. 5 times negative 4 plus 2q plus 18 equals 0. And we've got 2q, well, isn't that negative 20 plus 18? That's negative 2. 2q is, I'm going to go negative 2 plus 2q is 0. 2q is 2. Q is 1. And that's your solution. P is -4, Q is 1. Okay, so we've looked at all the different types. We've looked at elimination, we've looked at substitution, we've looked at when you subtract the equations, we've looked at when you add the equations together. Okay? Another thing you could have done was multiply equation 2 by -2, and you would have got -4p plus 6q minus 22 is 0, but then you would have needed to have subtracted the equations instead of adding them. See, I'd probably just not multiply by negative, more chance of making a mistake, and know that if the signs are opposites, two opposites, when you combine them, which means add them together, you get 0. Okay? Equations, equation 1 and equation 2. I think we did do things like this last year. What don't you like about it? The fractions? I think you just need to get rid of the fractions first, see what you end up with, and then we'll try and make something the same. All right? So equation 1 times what will eliminate the fractions? Times 12. And we get 12y on 4, isn't that 3y, minus 12x on 3, isn't that 4x? And 1 times 12 is 12. I'm going to call that equation 1a. What are you going to multiply equation 2 by? Equation 2 times 10. 5x plus 2y equals 100. Equation 2a. Still not the same. No easy way out. I'm going to have to multiply again. Well, let's make the y's the same. For a start, I'd be swapping positions of my y and x on the next row. Let's go for 6y. Do you know what I mean? I'm going to put here in little circles 6y. That's what I'm aiming for. See how they were opposites and easy to get confused. So I'm going to do equation 1a times what? If I want 6y. See, have it in your sights. Times 2. And I've got 6y minus 8x is 24. Call it equation 1b. And equation 2a times, I want 6y, times it by 3. Please put the 6y first. 6y plus 15x equals 300. Equation 2b. And off you go. Add or subtract. The 6y's are identical. If you add them, you get 12y. Subtract. Actually, stop. Do you want to do 2b minus 1b or 1b minus 2b? Yes, definitely do 2b minus 1b unless you want to work with negatives all the time. So 2b minus 1b, that minus that, 15 take away -8. 15 take away -8. Isn't that positive 23x? And 300 take away 24 is 276, I think. So x is 276 over 23. I don't know what that is. Right. And then just sub back into, look, equation 1 looks good. Sub that into equation 1. No, yeah. 1 or 2. Doesn't matter. I'm going into 1. So 1 is y on 4 minus x on 3 is 1. So we're going to put it into equation 1. Y over 4 minus 12 over 3 is 1. Y over 4 is, isn't that 4? Minus 4. 1 plus 4 is 5. $20. You get 20. X is 12, y is 20. Equation 1 times 3 to eliminate the denominator. What do you get? 12x plus y minus 2 equals 36. Are you okay with that? And let's put the 2, so I've got 12x plus y equals what? 38. So I would tidy it up. That's 1a. Then equation 2 times, what do you need to get rid of? The denominator. Need to get rid of this 5. Multiply by 5. Look, I know we could probably multiply by something else and try and get the x's and the y's the same, but it's just too hard to work it out in one step. So multiply by 5, we've got 15y minus, be very careful. What should I do before I write this x minus 3? I would put a bracket. Equals 30. let's rearrange. 15y minus x plus 3 is 30. And let's put the x under the... So, actually, I'm just going to leave it as 15y minus x equals 27. See, you know this equation, this question, I don't think you should do it by elimination. This is a really good case of using substitution. So, really, rearranging 1a, isn't 1a really y equals what? Let's rearrange 1a. So, rearranging 1a, I would not go multiplying this equation by this and that one by that. Definitely not. Let's rearrange 1a, and what have we got? Y equals 38, take away 12x, and sub it into 2a. So I've got 15 times 38 minus 12x, take away x equals 27. And now you can just expand and do whatever you want to do. I don't know what 15 times 38 is. Anyone? 420. Minus 1550, 180x minus x is 27. And then we've got negative 181x is, what's 27 minus, that's 3, negative 393. And x is, let's hope it's something nice like divide by negative 181. Is it something nice? Or is it a fraction? What's the fraction? I want it as a fraction. It's positive for a start. You can't simplify it. All right. 3 over 81, and then you would sub that into equation whatever you like. Equation 1a? I think so. And you would get 12 times 393 over 181 plus y equals 38, and then you can just work out what that is. Y is 38 minus 12 times 393 over 181. What do you get? I think the question is, there's a little error somewhere in the question. What do we get?
2162 on his 181.
Positive? I think it's negative. It's negative. Yeah, I think there's a typo somewhere in the question.